In this video, let us take up the second chapter of class 10 chemistry, that is the acid bases and salts. So the first thing is related to the introductory part of the chapter, and this defines what you mean by the acids as well as bases. So the sour and the bitter taste of food is due to the presence of the acid or due to the presence of bases in the food material. Usually acids tend to contribute to the sour nature and bases tend to contribute to the bitter taste of whatever the food product we consume. So acids are sour in taste and change the color of the blue litmus paper to red, whereas the same case is opposite in the base. So what happens usually, the red litmus paper turns blue in contact to the base. So litmus solution is also a type of a natural indicator which is been used. It is a purple colored dye which is extracted from a symbiotic association that is known to be as a lichen. So litmus solution is neither acidic nor basic. Generally its color is purple in nature. So there are other natural materials also. It can be the red cabbage, can be the turmeric, it can be the petals of the hydrangea or the petals of hibiscus, which tend to indicate the presence of the acid or base in the solution. The color change in these indicators depicts whether the substance is acidic or is it basic in nature. The next one is related to the properties of the acids. The term acid has been derived from the Latin word which means acidus. So acid means acidus in the Latin word, which tends to mean that it is sour. So we know that the taste of acids are sour in nature. So for that reason, they have derived the word as acidus, that is from Latin. So acids have sour taste. They generally turn the blue litmus paper to red. So they give H plus ion in the aqueous solution. Usually acid tends to give the H plus ions and the bases gives out the hydroxy ions, that is OH minus ions. The examples of certain strong acids are the hydrochloric acid, it can be sulfuric acid, the nitric acids, and examples of weak acids can be the acetic acid, oxalic acid, lactic acid, and there are certain concentrated acids also. Concentrated acids are highly corrosive as it can cause a lot of damage to the skin. So there is more amount of acid, less amount of water. So this phenomena is known to be as concentrated. Concentrated refers to the presence of higher concentration of acids. So if the solution has high concentration of acid, it is known to be as concentrated. Next we have dilute acid. Dilute refers to the solution which is having more the amount of water and the concentration of acid present is less. So in case of dilute acid, usually less concentration of acid is present. So most of the experiments, whatever we deal in the laboratory, we generally tend to use dilute acids because it is not much corrosive as compared to the concentrated acids. So if we take certain examples of the acids which are present in our day-to-day lives, so we can see the presence of the acetic acid in the vinegar, which is generally used in the preparation of food items. And if you take any sorts of the citrus fruits, so most of the citrus fruits tend to comprise of the acid known to be as the citric acid, and the tamarind has tartaric acid, the tomato, and even in case of spinach also you can see the presence of oxalic acid. Curd also comprises of citric acid. Along with citric acid, the largely it is having lactic acid. So citric acid is present in a very negligible amount. So usually it is present in with the lactic acid. The bacteria present is known to be as lactobacillus. So lactobacillus is the name of the bacteria which is generally present in the food. Next, if we take up the properties of the base, so these are the substances which are generally bitter in taste. Acids are sour in taste, and whereas bases are bitter in taste, they are even soapy to touch. So whatever the soap what we use It is soapy, right, because it generally has long chain fatty acids of the glycerol, so which is also a base in the major composition of soap, that is sodium hydroxide, right. That is the reason it is soapy in touch, and it is the property of base. So we know that whatever the red litmus is there, it generally turns to blue in the litmus solution. It gives out OH minus ions in case of acids, it gives H plus ions, in case of base it gives OH minus ion. The examples of strong bases are NaOH, KOH and calcium hydroxide, sodium hydroxide, potassium hydroxide and calcium hydroxide. And the example of weak bases, the ammonium hydroxide, that is NH4OH. So generally we give one more term that is known to be as an alkali. So these are the bases which are soluble in water. The bases which are generally soluble, which gets dissolved within the water, are known to be as alkalis, because not all bases are alkali. So examples are sodium hydroxide, the potassium hydroxide and the calcium hydroxide, which are also known to be as alkali. Alkalis are the bases which are soluble in water. Now let us take up certain chemical properties of the acids. The reaction of acids with the metals. So acids react with metal to form a metallic salt is formed, and there is also release of hydrogen gas. So that is the reason generally whatever the acids are there, they are not stored in metal. Acids are not stored in metals. So why is it not stored in metals? Because it tends to produce the hydrogen gas is produced and even formation of the metallic salt. So acids such as hydrochloric acid, if we take, is reacting with the metal, that is zinc. This tends to form a substance which is known to be as the zinc chloride. So this zinc chloride is formed, and there is also evolution of the hydrogen gas. So hydrogen gas evolution is a common phenomena whenever acid is reacting with the base. So if we take up the reaction of the base with metals, so base react with metal, which also results in the evolution of hydrogen gas. And also note that all metals do not react with the base. The metal must be more reactive. Only if the metal is more reactive, then what will happen? There is a reaction. If I take up the base, it is reacting with the metal. In general, it forms salt, and there is also evolution of the hydrogen gas. The example is zinc granules. If we are reacting with the base, that is sodium hydroxide, we tend to form sodium zincate. This is sodium zincate. Na2 ZnO2. Na is sodium, zinc oxide is there, so it is sodium zincate. And as usual, there is also the liberation of the hydrogen gas. So whenever the zinc granules react with the sodium hydroxide solution, it gives out the sodium zincate. It is a balanced reaction. What we see, there are two sodium, and the hydroxide is also balanced. Zinc is also one which is balanced, 2 oxygen and 2 hydrogen. So hydrogen gas is liberated in both the cases, whenever the acid is reacting with the metal, and even if base is reacting with the metal, that is the evolution of the hydrogen gas. So how do I determine the evolution of this hydrogen gas? It can be tested by bringing the burning candle near the gas bubble. It bursts with a pop sound. This is important, that if there is a liberation of hydrogen gas, there is a development of pop-up sound. This pop sound, the pop-up sound indicates that there is an evolution of the hydrogen gas. So next we have the reaction of acids with the metal carbonate. So usually whenever the acid is reacting with the metal carbonate, or it can be even the metal hydrogen carbonate. In general, it forms salt. Along with it, as hydrogen carbonates are there, it results in a formation of carbon dioxide and even water. So if you take the example of acid, that is HCl, it is reacting with the metal carbonate. In this case, metal is sodium and we have a carbonate group, that is CO3. Forming the sodium carbonate, it forms NaCl, and in this there is the evolution of CO2 gas and one oxygen from carbonate and one hydrogen which is present. It forms the water molecule. And similarly, if we take the example of the metal hydrogen carbonate, this was metal carbonate, and in this case we have metal hydrogen carbonate. If it is reacting with an acid, it forms a salt. That salt is NaCl is formed. The salt is formed as usual, and from the carbonate there is evolution of carbon dioxide gas. So remaining one oxygen is there, and there is one hydrogen is there, and here one hydrogen is there. So the two hydrogen with oxygen forms the water molecule. This is a reaction of the acids with the metal carbonate and metal hydrogen carbonate, which prominently gives a type of a salt, evolution of gases such as carbon dioxide and the water. So we tested in the previous scenario to determine how the hydrogen gas is released, that is by the development of the pop sound. So this carbon dioxide, if it is released, it can be tested by passing it through lime water. So if we pass the carbon dioxide gas into the lime water, so the lime water turns milky. So lime water is nothing but the calcium hydroxide. Calcium hydroxide is lime water. So if we pass the carbon dioxide gas to the lime water, that is calcium hydroxide, it results in a formation of the calcium carbonate and also release of the water molecules. So this calcium carbonate water, it is formed, it is our white precipitate. The calcium carbonate formed this, the white precipitate, which indicates that there is an evolution of gas, and that gas is the carbon dioxide gas. So if the excess carbon dioxide is passed, so then what will happen? The milkiness which is present in the lime water will disappear. Here we can see CaCO3, due to the excess of carbon dioxide, it has formed the product, that is calcium bicarbonate, known as calcium bicarbonate, which is generally soluble in water. So this is how the metals are getting reacted with the hydrogen carbonate as well as the bicarbonates, and the test which is used to determine the release of carbon dioxide gas, that is getting passed by the lime water. So in case of bases, if we see, so bases do not react with the metal carbonates and with metal hydrogen carbonate. There is no reaction of the bases with the metal carbonate and metal hydrogen carbonate, which results in the development of no reaction. So next is the reaction of the metallic oxides with the acids. So if we take up any sort of a metallic oxides, so generally what the metallic oxides are basic in nature. It is important. Whatever the metallic oxide we consider, it is basic in nature. Metallic oxide, if it is reacting with an acid, it forms salt, and there is also release of water molecule. So calcium oxide, calcium is a metal, and there is an oxide, so it is a metallic oxide. So this metallic oxide, it is reacting with the acid to form the calcium chloride. And there is also liberation of water molecule. It is a common phenomenon what is being seen. We can take up one more example. We have the copper oxide. Copper oxide, it is also a type of metallic oxide where copper is the metal and oxide is there, that is oxygen. If it is getting reacted with the HCl, so this results in a formation of the copper chloride. The copper chloride formed is the salt, and the remaining one is what? The water molecule. And I can balance this: 2 HCl, 2 hydrogen, 2 hydrogen, 1 oxygen, and remaining is the copper chloride which is formed. This is a reaction how the metallic oxide is reacting with the acids. So next we have the reaction of the non-metallic oxide with the bases. Non-metallic oxides are generally acidic in nature. If we take up the metallic oxides are basic in nature, and these non-metallic oxides, these are acidic in nature. The non-metallic oxide, if it is reacting with base, it tends to form salt and water. So the example of non-metallic oxide what we are taking is the carbon dioxide. Base is calcium hydroxide. It forms calcium carbonate and water. So whatever the calcium carbonate is there, that is the salt which is getting formed. So this tends to prove that whatever the non-metallic oxides are there, it is the acidic in nature. So next we have the reactions of the acids and bases which react with each other. So acids and base react to form the salt as well as water. This is known to be as the neutralization reaction. It is known to be as the neutralization reaction. When the acid is reacting with the base, it forms the salt and water. So these reactions are the neutralization reaction. So the example of neutralization reaction is HCl, which is the acid. This acid is reacting with the base NaOH to form the salt, and there is also liberation of the water molecule. If there is a reaction of a strong acid with a weak base, it gives acidic salt. If it is a strong base, it gives basic salt. If it is a strong acid and a strong base, both are strong acid, strong base, it gives out the neutral salt. If it is a weak acid and weak base, then also it is a neutral salt. It is neutral only when both the acids and bases are strong, or both the acids and bases are weak. In these two scenarios, we can see the development of the neutral formation of salt, or else whether if it is strong acid, acidic salt, strong base, basic salt is formed. So let us get into the effect of dilution on the acid as well as base. So acid, as we have discussed, produces H plus ions in presence of the water, and whatever the H plus ions are produced from acid, it is reacting with water and it results in formation of the hydronium ions. So H3O which is formed, it is the hydronium ions. And then what happens? So here we can see the HCl, which is an acid, it is reacting with the water. There is formation of hydronium ions, and there is also liberation of Cl minus. The Cl is getting liberated out because acid produces this H plus ions. The H plus ions are produced by acid. It gets combined with water to form the hydronium ion. So this is in case of the acids. In case of bases, when dissolved in water, it gives out OH minus ion. So it is very important that acid gives H plus ion and bases give OH minus ion. So the bases which are soluble in water, as discussed earlier, it is alkali. Examples for this is, you can take sodium hydroxide, take potassium hydroxide, or even you can take calcium hydroxide. These are certain examples of alkali. So when we dilute the acid. It is recommended that acid should be poured to the water and not water inside the acid. You need to always remember that you should always pour acid to water. Always pour acid into water. If you reverse it, if you tend to add water into acid, it tends to give out an exothermic reaction which is highly explosive in nature. It results in the bursting scenario. So it gives out exothermic reaction. So that is the reason always we need to add acid to water and not water to the acid. So the next topic is related to the indicators. So generally we cannot taste each and every acids and bases which is present within the laboratory. So we need to have certain compounds which are known to be as the indicators, so which tend to indicate whether the substances which is present is acid or bases. So how can we identify whether it is an acid or base? It may be due to change in color or it can be due to change in odor. Based upon these two as a major criteria, we can determine whether the acid or base which is present within the substance. So there are usually four major types of indicators which is been used. In that, the first type of an indicator is the natural indicator. Natural indicator comprises of the litmus. So litmus, which is it is red in the acid medium. I'll consider this as acidic and I'll write the basic media over here. Litmus is generally red in case of acid and it is blue in case of base. So red cabbage is also an indicator. If you take up the leaves of red cabbage, boil the red cabbage leaves, the pigments are getting extracted out. So whatever the pigmented water is there, it is acting as an indicator to determine whether the substance is acidic or basic. So generally it appears to be red in the if the substance is acidic. If the suspend is basic, it is green in color. So again, similarly, turmeric water can also be utilized as a natural indicator. So it is generally yellow in acidic. If you add any acidic substance, the turmeric water, it does not change its color. It appears to be yellow as such. And if it is basic, it changes to red or reddish brown. And if we take up the hibiscus petal, it generally appears to be, or rather than hibiscus petal, the most common one is the hydrangea. In case of hydrangea, the acid is bluish in color, and if it is a base, it is pinkish in color. In this way, we can distinguish if the substances are acidic based upon the color, and if the substance is basic based upon the color, using various natural indicators. So we have the other two synthetic indicators. The first one is the phenolphthalein, THALEIN. So phenolphthalein, which is generally in case of the acidic medium, if I take it is colorless. So generally whenever we perform titration in chemistry lab, we use phenolphthalein as an indicator, and if it is a base, it appears pink in color. If it is a base, it's pink in color, and in certain cases, if it is neutral, it is colorless in the neutral state. In case of methyl orange, it is red in color. If it is acidic, it is yellowish in color if it is a base, and methyl orange appears to be orange in color if it is neutral. In this way we can distinguish based upon color. So it is colorless in acidic, pink in base, colorless again in neutral. In case of methyl orange, red in acidic, yellow in base, and orange in the neutral state. So then we have this olfactory indicators, which is the indicator based upon odor. Odor refers to the smell. These are the substances which change their odor in the acid and base media. So usually the smell of the indicator change whenever it is getting exposed to the substance comprising of the acidic or the basic nature. So the common examples what we use is the vanilla extract as well as the onion, which has been used as olfactory indicator. And usually what we see is that it tend to change its smell only with reference to acids. So with reference to base, there is no odor. So there is no much odor experienced in case of the base. It can be only detected in presence of the acids. So next is the universal indicator. So this is to judge like how strong is the acid or the base, because it is generally a mixture of several indicators. Most of the indicators get mixed and a common indicator is formed, that is the universal indicator. It shows the different colors at different concentration of hydrogen ions in solutions. So based upon that, the stripes are there which indicates the color based upon the concentration of hydrogen ions. So pH is generally considered as one of the common universal indicators. So how do we determine the strength? That is with the help of an indicator, that is pH. It is a scale for measuring the H plus ion concentration in whatever the solution you take. So P, which is present within the pH, stands for the potence, which is the general word meaning of power. So the word pH is nothing but the power of hydrogen. The power of hydrogen is pH, and this has been derived from the German. So it generally ranges from the 0 to 14, and in between we have 7. So from 0 to below 7, it is generally acidic in nature. It is considered to be as acidic, and more than 7 up to 14, it is considered to be as basic, and at 7, it is considered to be as the neutral. So you can take up various examples like the gastric juice, whatever it is secreted inside the body, right, due to the process of digestion. Usually these kinds of juices are being released within the stomach, the intestinal juice which is released in the intestine. So they have a pH of almost about 1.2, which is highly acidic in nature. And you have the lemon juice which is having citric acid, so it has the range of 2.2. And then for neutral, we can take the example of the water what we drink, or blood which is flowing in our body. These are the major examples of the neutral one. And for base, the major example of the base to be considered is the milk of magnesia. Milk of magnesia is also known to be as the antacid. So whenever there is high level of acidity in your body, by consuming the milk of magnesia, it gets neutralized. For that reason, milk of magnesia is also known to be as antacid, which has its pH of 10. And the most common, the most basic base is the NaOH, which is having its level 14 in the pH. So these are various examples what we can take to understand the pH values. So the next topic is related to the importance of the pH in everyday life. The first one is related to the pH sensitivity of plants and animals. Usually most of the animals and plants what we see, they generally tend to use the neutral pH. They do not prefer to have highly acidic or the basic soil in case of plants, or the food in case of animals. So that is the reason these plants and animals are highly sensitive to pH. So whatever the crucial life processes are there, they all occur at certain pH value. So digestion may occur at certain values, excretion may occur at certain values in case of plants to grow a certain crop. Few plants require the acidic soil medium, few crops require alkaline media, few require neutral media. So to grow any sort of crop, we need to determine first the pH of the soil, then we can take up. So pH of soil is another important thing, as usually the crops prefer 6.5 to 7, that is slightly acidic or most probably neutral. If you take up jasmine as the example, it tends to prefer more of the acidic soil, and whereas most of the common flowers such as the roses and petunia, if you take it, uses 6.5 to 7 as its normal pH range. Next, in case of digestive system, the process of digestion happens at specific pH in our stomach. Usually what happens in our stomach, there is a release of the hydrochloric acid. The presence of hydrochloric acid is very essential because for the digestion of proteins, the proteins get broken down into the amino acids. The amino acids are absorbed by the blood. So for that digestion purpose, hydrochloric acid is essential, which pH ranges from 1.5 to 4. It is usually below 4, ranging from 1.5. The pH results in the activation of most of the enzymes. There are various enzymes which is involved in the digestion of food, and these enzymes are getting activated only if we provide the optimal pH. Optimal pH is the condition which allows the enzymes to get activated. Once it gets activated, the life process is accomplished. And the next one is the pH in tooth decay. So whatever the food we consume, it is rich in sugar. So there are certain amount of sugar residues which would be left out within our mouth. So in that scenario, what happens is that the bacteria tend to feed upon those leftover sugar in the mouth, and they release the acid material as the fecal matter. So that is the reason it is advised to brush twice a day, in the morning as well as the night, so that the paste comprises of the basic media. We tend to neutralize whatever the acid is produced within the mouth. So tooth decay happens when teeth are exposed to the acidic environment of about pH 5.5 and below. Usually this occurs due to the action of bacteria. Bacteria tend to release out the acidic condition inside the mouth. So to neutralize it, we use various toothpastes. So these toothpastes are basic in nature. So due to this, it results in the overall neutralization. So the last point is related to the pH of self-defense by the animals and plants. So acidic substances are used by animals and plants as a self-defense mechanism. If we take bee and the plant like nettle, they secrete highly acidic substance for the self-defense. So these secreted acidic substances have certain specific pH also. Usually the acid released is the methanoic acid. So whenever there is a bite by the bees, the bumblebees, or any sorts of the insects, so they tend to inject the methanoic acid. This methanoic acid causes inflammation to our skin. So to counteract what happens, so we generally use a certain amount of base or the ointments which are enriched with base so that it can neutralize. So usually this areas which have got infected due to methanoic acid, we can rub the affected area with the leaves of dock plants, which is generally present in the nearby scenarios also. So this dock plant helps in preventing whatever the inflammation has occurred due to the acid which has been released by the nettle plants which is getting released out. So these are certain examples of how the neutralization reaction has been occurring in a everyday life. By this we have covered the topic